here, I have 62 here. Equal angles, opposite equal sides.
So
Yep.
isn't the reason isosceles triangle?
Yeah. So isosceles triangle, don't forget, if you look up here, angles opposite equal sides, isosceles triangle. So if you look at the documents I gave you in grade 10, 11, 12, we can't say isosceles triangle. We have to use this reason here, which means isosceles triangle, right? So every time you see isosceles triangle, you're going to say angles opposite equal sides. Basically, this is what it means. I don't know if you can see where I'm about to draw now. You're able to see where I'm drawing on your screen? Can you see this triangle I drew?
Yes, sir.
You can. Okay, good. So then, let's say if this is an isosceles, right? These two sides are equal. So I'll tell you why it's equal angles opposite equal sides. You see, this angle is opposite there. You see, this angle opposite there. You get the idea. So in grade 10, they don't say isosceles triangle. They say angles opposite equal sides, or you can say equal angles opposite equal sides. All right. So thanks for asking. So E1 is 62. There's it there. LE equals LM. It was given, right? Also given. And then M1 is 62. Why? Because equal angles opposite equal sides. So that means using interior angles of a triangle, I can now figure out what's that angle. So 180 subtract 62 will give me that angle L. Right? So L is equal to 180 minus 62. Minus 62 will give me 56. Sum of interior angles of triangle. But note something. This is 56. This is 56. Adding up these two angles, let's see how much that is. So if we add up those two angles, so L is equal to angle N. So angle L is equal to angle N, both is 56. We proved that N is equal to 56 above, okay? So if you check above over there we proved that it was 56, right? So now we got one pair of opposite angles that are both equal to 56. So if you take P1 and P2, add them together. Don't forget that P1 was 68, P2 is 56. Adding them together, add these two angles and see what happens. So when you add those angles up, notice we get 124. We get 124. So angle M is 124. Angle P is also 124. So now when we have a shape, a four-sided shape where the opposite angles are equal and the opposite angles are equal, two sets of them, we can conclude that it's a palm. So M is equal to P. Sorry, the camera fell. M is equal to P, and our reason is opposite angles of a palm are equal. So opposite angles equal of a palm. Okay, does that one make sense, guys?
Yes, sir. Sir, is this still part of theorem 1?
Yes, this is theorem 1. Okay, so the first few examples, lesson 3 and 4 is theorem 1. Okay, so these were the examples that followed theorem 1. Okay, do you all have that written down? Should I push this up at the end if you can see all the writing there? Just tell me when to stop. You can all see the writing? Opposite angles equal?
Yes, sir.
You can. Okay. So what you do, write down all that. That will be the answers, right? To part B. To part B. Okay, after this, we're looking at exercise 2, number 2, which will still be theorem 1. Are we all written up? Okay, so we're all sorted. Right, next one. The next one will be exercise 2, number 2. Okay, so exercise, just tell me once you can see the diagram. Assume somewhere you should be able to see. You can see the diagram, guys. Any one of you to say yes?
Yes, sir.
Okay, perfect. Right, so PQRS is a palm. Okay, so PQRS is a palm. This means we'll use all the properties of a palm. So first step, what I like to do when you get a test or an exam is to take this information and write it on there. So because it's a palm, you know in pencil that this side will be parallel to that side, because parallelograms have opposite sides parallel and equal. So add it into the diagram, right? With P is equal to 60, so all of this angle here, P is 60. Now there's two ways of writing an angle, right? I could also write angle P like this, QPS. Okay, so PQS is equal to 60. You see, this is how you have to use this notation sometimes in the diagram when there's no ones and twos written. You get what I'm saying? So you'll have to use QPS. So the middle one will be the angle. So this is an alternative notation which you might need in a test. Okay, and PQ is equal to PS. So PQ equals PS, that is given. Calculate the sizes of R. So R is this one, S1 is that one, and so forth, right? So let's see, R is normally going to be the easiest one. Who can tell us what R will be? R will be how much? I'm just teaching online. R is
Sir,
equal
would
to
it be 60 degrees?
60, perfect. What's your reason there, Lawton? Opposite angles of a palm, right? Opposite angles of a palm. So that's the first one. R is equal to 60. I'm not too sure if you can see the red writing here, guys. So R is equal to 60 opposite angles of a palm. Okay, so R is sorted out. Let's go to S1. Looking at S1, you agree that S1 will be equal to Q1. You agree, definitely, right? Why? Because this is an isosceles triangle. Notice we won't use that reason. We would say angles opposite equal sides, even although it's an isosceles. So S1 equals to Q1, angles opposite equal sides. In brackets is put isosceles, so you know what that means, right? Isosceles triangle. But never use the reason isosceles. Always write in the exam angles opposite equal sides. Right, so we're good. So if we take that value, the screen is doing some funny things. Recording has started. Okay, that's fine. All right, so this one will be, S1 will be how much, guys? Anyone has an answer for S1? S1, anybody? So if we take 180 and we subtract the 60, what's the balance? The balance will be 120. 120 then divided by 2, that's going to give us 60. Okay, so S1 will be 60. Q1 will also be 60. So let's check that. 60 plus 60 plus 60 is 180. So Q1 is equal to S1 is equal to 60. Sum of interior angles of a triangle. Let's look at Q2 next. Q2 is equal to S1. What reason can I use there? Anybody? Q2 is equal to S1. So don't forget what the entire shape is. The entire shape is a palm. So S1 is equal to, am I making a mistake there? What am I trying to do? Oh, Q2, sorry, I'm busy trying to find Q2. So Q2 is equal to S1. Q2 equals S1. Our reason will be alternate angles, perfect. PS is parallel to QR. So PS, alternate angles, PS parallel to QR. Next we want to find S2. So S2, that's this one here. S2, so I'm using double line now to show that it's not that angle, right? So double line here, would mean that this angle here, this double line angle, will be equal to that double line angle. Notice it's also alternate angles, and it's alternate angles PQ parallel to SR. So notice this abbreviation is acceptable. ALT dot, the angle sign, always include this in the reason. If you don't put this in, they're not going to give you that mark. So most times in the exam, this whole statement, all of this plus all of this is only 1 mark. If you leave out this part, they're not going to give you that mark. Okay, so please be careful. Geometry, you can know it, but if you don't write everything, it's a problem. Right, class, I hope you've written all that stuff down. The next one we're going to is exercise 2, number 3, page 195. I'll repeat. Exercise 2, number 3, page 195. Okay, you're able to see the diagram, I'm sure. Exercise 2, number 3, page 195. Right, this is clearly a very simple one, right? It's more like a grade 9, but you find that some don't get it. So the first thing we need to say is that all of this angle equals all of that angle. So we know that K is equal to angle M. So we need to have a reason why we're saying that. So let's look at what information they gave us. They said that KLMN is a palm. So we know that the opposite angles of a palm are equal. So first statement, we're going to say K is equal to angle M. Our reason will be opposite angles of a palm are equal, and then all we'll do is substitute angle K, so all of this is equal to all of that story. Alright, so that's our very first step. Alright, so you can just copy down the red writing there. Next, we're going to have to solve for x. Okay, that will be the very next step, is to solve for x. So our solving skills have to be in. So practically, that's a plus 3x. Take it over, minus 3x. Minus 12, take it over the equal to sign, will become plus. So inverse operations, 5x minus 3x will give me 2x. And 18 plus 12 will give me 30. So 2x is equal to 30. Divide both sides by 2. We'll be left with x on the left-hand side. The right-hand side, 30 divided by 2 will give us 15. X is equal to 15. All right, not too difficult. That was kind of an easy one. Write down that's in the red in the meantime. The next one we're going to do there, class, will be exercise 2, number 9, page 197. So exercise 2, number 9, page 197. Okay, so all you can do, instead of writing the diagrams, just write exercise 2, number 3, page 195. 197. Exercise 2, number 9, page 197. Just write that on the left. Later you can just draw in the diagram, okay, to save time, so we don't have to use too much data. As long as you got the solutions on the right hand side. Okay, if you didn't get the solutions, I'm going to, what can I say, I'll scan this notes of mine and then I'll send it on the group anyway. Okay, so in case you didn't get the writing, as long as you understand the concept, you could, if you don't want to write, it's fine. I can always send it to you afterwards in the group, not a problem. Okay, let's go to the next one. Okay, so we said it was exercise 2, number 9, page 197. Right, so it says in parallelogram, or in palm, ABCD, AB is equal to 50, and E is a point on AD. So E is a point on AD such that AB is equal to AE. So where is AB? Okay, AB is this one. AB is equal to AE. So again, isosceles triangles are kicking in. Okay, so it's good to take this information and write it on the diagram, okay, even in a test and an exam. CD is equal to DE. So CD is equal to DE. So these marks, class, indicate that they are equal sides. The arrows mean parallel, right? Determine, so they want us to find the value. So DE. So when I say determine DE, that's an indication they want us to find the length. Okay, so the length of DE. Okay, so don't get confused. Right, so DE we know is also equal to BC. We also know that this is equal to that. So if you understand what a palm is, now class, notice that these diagrams are not drawn to scale. Do you notice that E is not really in the center? Can you see it's like off-centered? So don't look at the diagram and say, oh, well, E is not really in the middle, so therefore this one cannot be equal to that one. You see, don't get caught in a trap. So the thing is what they're trying to show us here, if you look nicely. They told us that this shape is a palm. And if it be a palm, which it is, then CD must be equal to AB because we know that the opposite sides of a palm are equal. So that would mean if CD equals AB, then this side is equal to that side which is given, then surely AE must be equal to ED. So do you see how simple this question is? It's very simple. So this side is equal to that side, opposite sides of a palm. This one is equal to this one given, but this one equals this one, and that one equals that one. So if this is 50, so notice AB is 50. So AB is 50, that means CD is 50. CD was told to be equal to ED, so this is 50. AE is equal to this one, so this one's also 50. So class, is this a simple example? Very simple. What's the perimeter? This is 50, that's 100. This is 50, that's 100. You see? So we have already answered all of that. Let's start all again. So AB was given equal to 50. So AB is equal to 50 given. DC or CD is equal to AB, opposite sides of a palm. Right? Are we good there? Opposite sides of a palm are equal. Therefore, DC is equal to 50 centimeters. So DC is 50. So we were told that this side is 50, so the other side is 50. I think one of you got your mic on. If you can just mute your mic because it's going to give feedback. I think it's Tando. Tando, if you can just mute your mic. Thanks. It's got like a little speaker thingy there in the bottom somewhere. Right. If you come down here, we said that DE is equal to DC, and that was given. Therefore, DE is 50. DE is 50. Right, now we're going to the second part of B, finding the perimeter. So AE is 50 because this side was 50, right? Because AB is equal to AE, and we know that is given. So AD is equal to 50 plus 50, which will equal 100. Therefore, BC is also 100, opposite sides of a palm. So if this is 50 and that is 50 and AD is equal to 100, therefore BC is also 100, opposite sides of a palm. Then we have to use the perimeter formula. Perimeter is equal to 2L plus B. Substituting into there, you don't really have to write the formula down. So 250 plus 100. So that one is 50. That one is 100. So it's 250 times 100. You get it? So 50 and 100 is 2 times. You see, this is the center, the halfway mark. So this is a this is an exact replica of the other side. So 250 times 100 will give us 300 centimeters. Right, I hope we're good on that one. Are we understanding, guys?
Yes, sir.
Okay, good. Right, next one, we're looking at exercise 3, number 1, page 200. The next one will be exercise 3, number 1, page 200. Right, exercise 3, number 1, page 200. This will be lesson 5 and 6 PDF. Lesson 5 and 6 PDF. So we're looking at parallelogram, PALM, A, B, C, D. So they're telling us that A, B, C, D is a PALM. You agree, A, B, C, D. Let's just shade it in, so you have some sort of idea. Right, so this one here, guys, A, B, C, D. So that whole shape is a PALM. Already in your head, what theory, these ones are based on, let me think, Theorem 2. So all these diagrams I'm doing next are based on Theorem 2. Theorem 2 says the diagonals bisect each other. Okay, so if we're given a palm, why did they draw this palm to connect with the diagonal? Because you're going to use the diagonals of a palm bisect each other to prove that this is actually a palm. You see how this works? So just by looking at it, I can tell you that this side is going to be equal to that side, and my reasoning will be opposite sides of a palm. They tell us that A, B, D, E is also a palm. This one here is also a palm. It's a pity I don't have another color or darker pencil. Okay. This one is also a palm, right, guys? Also a palm. Now, notice that this side of this palm also connects this palm. So this side is common to both palms. Can you see the palm going this way and the palm going that way? So now, opposite sides of a palm are equal. So that means AB is equal to DE. You see that? So now, that means this one is equal to that one. Can you see the circle? So this circle, this side, was equal to this side. This side is equal to that side. Therefore, this side is equal to that side. This thing is now a palm. Why? Because you have diagonals bisecting each other and diagonals bisecting each other. This stuff is too easy. Okay, so let's start. We'll start writing down. First, we're going to say DF. So DF is equal to DB given. So DF is equal to DB given. We always start off with the given stuff. DC. So DC is equal to AB, opposite sides of a palm. So we're just writing in the palm there, right? A, B, C, D. So we know which palm we're referring to, okay? Then we're going to say ED is equal to AB, opposite sides of a palm. Therefore, DC is equal to ED. So class, you notice, if this one equals that one, this one equals that one, these two are the same, right? So that means those two are the same. So if you keep writing it in such a way that you keep the AB on one side, the eyes are easy to see that therefore DC will be equal to ED. Right, so therefore DC equals ED. Therefore BC FE is a palm. The diagonals bisect each other is the reason. Okay, is that quite simple? Not too hard?
Sure.
Perfect. Right, so guys, I don't know if you've written up already. I'll just give you like 2 seconds or so, and then we could move to the next one. The next one will be exercise 3, number 2, page 200. Exercise 3, number 2, page 200. Right, ABCD is a palm. ABCD is a palm. And DC, this is this one here, DC is equal to BN. So DC equals BN. Guys, am I going too fast? Just let me know. Anybody?
So I think just please slow down a little bit.
Slow down a bit. Okay. Slow down a bit. Okay, cool.
Thank
Right.
you, sir.
Okay. Right.